Hi, welcome to part 2 of the lecture for protocols and models. Now we're going to be into, I think it's section 3.2 on protocols. And we're going to kind of go over kind of an overview of network protocols. There are different types of protocols that are used, but basically just remember, protocol is just a set of rules. It's a common format and a set of rules that allow messages to exchange between devices, whether it's your phone to computer, or computer to your phone, whatever the case may be. Now, there are 4 different types. You've got network communication protocols, you've got network security protocols, you have routing protocols, and service discovery protocols. Network communication protocols enable 2 devices to communicate to each other. There's a couple out there. You'll see various names. You got Internet Protocol, IP, Transmission Control Protocol, TCP. You say, oh, TCP, IP, you think you've heard that before. Or on a web browser, you've probably seen Hypertext Transfer Protocol, HTTP. Every web browser you look at, you will see HTTP or HTTPS for the secure one. And there's a whole lot of communications out there, and we'll get to a lot of them in this class. Then you got network security protocols, and basically those are ways to authenticate and check that you are who you say, and they encrypt data. Routing protocols make sure that messages get between 2 destinations the way you want. And then service delivery, service discovery protocols are used to do automatic detection of services between equipment. Right now, you use most of it in your DHCP. I mean, most of you don't have every IP address memorized, but you have somebody has set up all those rules for you so that when you turn your computer on, it automatically goes out and gets the IP address, the gateway, IP address, the domain name service. All these things are preloaded for you, and all you've got is to turn your computer on, and it was found for you. Now, some of the functions of an IP protocol. There are communication protocols that are responsible to send data between devices. Now, you see here, I keep forgetting that, there are 2 different things. One, you've got data that you want to send. All this other stuff that you're going to encapsulate, you're going to wrap around this, because what happens is these devices, if they don't understand IPv4, they won't pass the message on. So there's some basic steps that need to be agreed upon when you do this. I've got to agree on the addressing scheme, sender and receiver, whether it is going to be Ethernet, it's going to be IPv4 or IPv6. So the addressing method has to be agreed upon. The reliability, how much do I have to make sure this message gets through perfectly? If you send a message, you want to make sure it's guaranteed, you're going to send it over TCP, which provides a guaranteed delivery service. It basically says, hey, I got part of a message. I'm going to check it for integrity and make sure none of the bits have got swapped or changed or modified. And if I got it through and it passes, I'll keep it. If not, I'll send back an acknowledgement saying, hey, resend that package. Flow control basically is and shows the data flow, efficient rate in which messages can go between 2 devices. How fast are things going to go? And TCP provides a flow control services. Because I've had agreed on message sizing, I probably had to break up my sending you War and Peace into smaller segments. So somebody's got to keep track of, make sure you get segment 1 followed by segment 2, 3, 4, and so on. So somebody's got to control who's going to do the sequencing, controlling that, making sure that what happens to things out of order. You also worry about error detection. Has something happened to this message between point A and point B? How do I know it arrived cleanly? And there's various protocols that will provide that. IPv4, IPv6, Ethernet does, and TCP. And then there's some things that are application driven. And most of us use the internet, and HTTP and HTTPS are two protocols that are application interfaces. So I look at it and says, okay, how do I, if I'm sending a message to a computer, how do I have all these different layers interface with each other? Well, first thing I've got down at the bottom is I've got this is your Ethernet. This is my physical environment. This is which media am I going to use, and how is my device going to put it into that format? Is it going to be going over the airways? Is it going to go over electrical wires? Is it going to go over an optical link? So I've got to define what the physical properties are of that. Then I have to have the addressing, the internet protocol addressing, whether it's IPv4 or IPv6, I got to have an address. Then I got to say, okay, how am I going to control the conversation? Like I saw, is it going to be, how fast am I going to flow? What's that flow control? TCP worries about managing that individual conversation. And of course, this interface is, HTTP governs the web server information to say, hey, how do I want, which server do I want? Which page do I want? All of that stuff. So application, you got your flow control, you got your addressing, and then your physical components. So you got your hypertext terminal, that's your protocol that governs the application. Then you got your flow control, your TCP manages the conversation, make sure you got reliability, your IP handles the addressing, and your Ethernet is the protocol that controls how do I get things from your network interface on your physical device, on your phone, your network interface on your phone or your computer, to another network interface. And that's what NIC stands for, is network interface. But it's got to be on the same network. Somehow I got to make sure that my addressing is correct. I'll let you worry about testing your ability. Let's look at protocol suites. And you kind of get a little picture of a protocol suite, but protocol suite is basically a group of interrelated protocols to make sure things happen from end to end. So that's really all they are. I'm not going to go through that. But we've kind of got an evolution as for how do they all come across. I mean, there are several different standards out there. You've got TCP/IP. It's one of the standards organizations that we'll talk about in the next section. Created one to make sure that everyone's on the same page. Now, it started out the International Standards Organization's protocol would have been the one that everybody was hoping to come to agreement and use, but it took too long to come to market. So the industry kind of came up with TCP/IP and came up with a little bit of different layout and which protocols and rules are in which bucket. And then you had your physical layer. So you've got a network access, so that worries about the network interface card, how I'm going to mechanically change your data to put it on a particular media, whether it's Ethernet, ARP LAN, a wireless LAN. Then I've got my internet protocol. This is how I'm going to address it. IPv4, IPv6 version. Then I'm going to say how am I going to control my message, my packet. There's two basic out there. One, TCP, which means I'm going to guarantee the content, or UDP says I'm going to let the end user decide what they want to do with it. And you see a lot of video and audio transmissions use UDP because there's so much data going across to check everything and make sure it's correct. It would take too long. So they're just saying, I'm going to send it and I'll let the end user, end service worry about handling it. And then you got the different applications you're going to use. And we've talked about a few of these, and we'll go into a lot more detail later. But you can see there's TCP/IP, International Standards Organization protocols. Apple had their own, they may still do, but it's not very well used. And Novell had one for a while. So these two aren't used very much. This is for educational purposes, and TCP/IP is actually the one that's used by pretty much all devices. Now, here is an example of the TCP/IP protocol, and it just kind of goes through my network interface. Says, okay, I'm going to use the protocol I'm going to use is Ethernet, because why? I am connected to a physical wire, so I'm going to go over an Ethernet cable. Now, IP says I'm going to have to worry about some kind of addressing. So what address I'm going to use? And of course, you've got to choose if it's IPv4 or IPv6. And then you got, how's it going to control? This one says, hey, I want to make sure my message is controlled and it gets there accurately. So I'm going to choose Transmission Control Protocol, TCP. And I'm sending it to a web server, so I'm going to use the Hypertext Transfer Protocol, HTTP. Now, when you look at the TCP/IP protocol suite, the whole suite of tools, you'll see that there are several different sub-devices or protocols inside each packet. Now, on the network access layer, you've got an address resolution protocol. Most of us don't know an IP address, don't know the address of who you're sending it to. You may know an email address, you may know a web address, but you don't know the IP address. Well, address resolution says I'm going to take a name and convert it to a number. So it converts that data. Data link protocols are based on what's the next step to the next intermediary device, which media am I going by, and I've got to change my physical rules of the transmission. Is it going to go over the airways? Is it going to go over the wire? Is it going to go over fiber optics? So I've got to change that mechanical interpretation of the message being sent. And then if I go to the internet layer, I've got several different addressing seeds. I got IPv4, IPv6. There is something we'll talk about later, network address translation, because IPv4 addresses are running out. IPv6 is the new way we're moving to, but I've got to maybe translate between the two. I've got to make sure that I get, they created network address translation to kind of preserve a limited number of IPv4 addresses. You've got certain messaging. You may have heard of a command called ping, which allows me to see if another device is at the other end. Well, actually the ICMP protocol is for that ping. And then there's also different ways of getting it between different devices. There are certain routing protocols of getting between your switch, your router, to the end router and switch, and what's the best way to get there and how fast it gets there. And that's where you see these routing protocols. Then you got the transpic. We've talked about, if I want to make sure it's connection oriented, which means I want to make sure I got a connection, I want to make sure that the data gets there correctly, I want to use TCP. If I could care less, it's connection less, I'm going to send it, and I'm going to worry about all the downstream devices, worry about how to manage all that. And then when you look at the application level, there are a whole lot of applications for email, for hosting, from name service to web services. All of these applications are ones that will be exposed to. Of course, you can go through and here's a list of the different applications and a little bit of description. I highly, highly, highly recommend you do that, to go through that list to make sure you understand, because you will need to understand those. The communication process basically says, hey, this animation tells me, because I've got only one data, but I've got all these different layers that have to go through. So I want you to watch this video to show how data gets, how the IP address, the TCP, the physical internet, all that stuff gets added to your message. I want you to go through and watch that. And I am not going to run you through the quiz. So that will be the end. I will start with standards on the next video. If you have any questions, let me know. Thanks.